So in this lecture, we'll be starting with the design of tension member. Okay. So in the tension member, my dear, there are some important topics from which the question could be asked. The first one is, of course, the net area, because when we find out the strength of the tension member, by using the net section rupture criteria, we need to find out the strength most of the time. So the computation of the net area is very important. Now the net area could be asked for a simple flat plate, or it could be asked for an angle section with one leg connected or two leg connected. Both the legs could be connected. Up till now, what they have been asking in the GATE examination is simple flat, or you can say a plate section with a chain pattern or a staggered pattern. So that, if you see the previous year questions, definitely you'll find those kind of questions over there. So those things you need to prepare. But now the next thing, what could be the next thing that they could ask? They might even ask for the angle section also. So you need to make sure that you need to know how to find out the net area for an angle section connected to the gusset plate when a single leg is connected or both of the legs are connected. This is the one thing. Another thing could be that what is a shear lag effect. Basically the strength of tension members are most of the time affected by the shear lag effect. So you must know what is a shear lag effect and how to compute the strength of the tension member after the shear lag is coming into the picture. If there is no shear lag, then there is no problem, but once there is a shear lag involved inside the tension member, then how to find out its strength. You should be thorough with that. Next, the other criteria, the cross section rupture, the cross section yielding criteria, we have net section rupture criteria, and the important one, block shear as well. Up till now, they haven't asked any single question on the block shear, but I really think that there might be a very high possibility, there's a very high chance that a numerical, a 2-mark numerical could be formed on the block shear criteria. So in this lecture, we'll discuss about a question based upon the block shear criteria as well. And my dear, lastly, there could be a question upon the slenderness ratio for the tension member. Now yes, slenderness ratio is important for the compression members, but when tension members are subjected to reversal of stresses, then there is some limitation given by the code over the slenderness ratio for the tension members as well. So these are few topics through which you should be anticipating that the question might come into the GATE examination. Alright, so let's get started with the first question of tension member. So here what is written? You need to find out the net width of the plate section as shown in the figure, considering the bolt size of 18 millimeters. Okay, so simple, a diagram has been given to you, the entire pattern is observed. So here you must see, my dear, the pattern is in which you can say in which particular category it is going up, down, up, down, up, down, like this pattern. So what is this? This is basically a zigzag pattern, and whenever we have a zigzag pattern, you have to apply the Codal formula of P square by 4G, considering number of variety of cases through which this plate section can fail under the tensile loading. So whichever comes out to be the minimum width or minimum area while you can say the load would be applied. Once we apply the load over here, of course the minimum area given by this plate section after the placement of bolt holes will be the one which will be generating the you can say first, it will generate first limiting stage of the failure. So you need to find out the minimum dimension, basically the minimum width. Once you have the minimum width, then only you will be able to find out the minimum area. That would be nothing but your net critical area. So likewise, this question you might have done in the classroom. So let us just repeat it and revise it how we used to do it. Alright, we need to find out net width, and this is the diagram. So let us consider the diagram first of all. Let us say this is the plate. Okay, so how many lines of bolting we have? The lines of bolting we have is 1, 2, 3, 4. There are 4 rows, you can say. So draw the 4 rows. This is row 1, row 2, row 3, and lastly row 4. Okay, so this is the, you can say, the placement. And what about in a single line? How many we have? In single line we have 2 bolt holes present, 2 like this and 2 like this. So now place the bolts. So we have got line like this, then we have the another line over here, and the pattern is, my dear, staggered. So if you have 2 holes over here, the another 2 holes is over here. If all of them are in single line, then it would be treated as a chain pattern. Once you can see these are up and down motion, that means it's a staggered motion. And now all you need to do is just repeat it up. Okay, now you need to just repeat this thing throughout the plate. Okay, likewise you can say you have the entire connection. Now what are the important parameters while solving this question? My dear, the important parameter is the previous width, or you can say the total width of the plate. This should be known to you. What is the total width of the plate? That you can get by the diagram. What else do we require? My dear, we'll be requiring, very important, the pitch distance. What is the pitch distance? It is the center to center distance between the bolt holes measured in the direction of loading. As it is a staggered pattern, so this is a staggered pitch. And what about this? My dear, this is what we call as a gauge distance. Okay, this is the gauge distance. What else we require? We will be requiring the diameter of bolt hole, as the diameter of bolt is given. Diameter of bolt is given how much? 18 millimeters. So what is diameter of bolt hole? Diameter of bolt hole would be 18 plus the clearance we need to add. We add 2 millimeters, so the bolt hole diameter is 20 millimeters. Please cross check with the given figure. So the pitch distance, as you can see, the pitch distance is how much? You can see from this diagram, it is given as 40 millimeters, while the gauge distance is how much? 50 millimeters. This pitch distance is given as 40 millimeters and this gauge distance is 50 millimeters. What about the end distances? End distance is given as 30 millimeters. So my dear, from the given figure, what is the total width? Total width of plate is equal to how much? So this is how much? 1, 2, 3. All of them would be 50, 50, 50. So 3 times 50 plus the end distance. How many end distance we have? 30 this side, 30 this side. So twice of 30. So this would be equal to 150 plus 60. That is how much? Total width is 210 millimeters. Okay, this is the previous width. Now because of the bolt holes placement, there will be some reduction, and whatever the after the reduction the plate width remaining is there, that is what we call as the net width. So we need to find out the minimum value of the width. For that, my dear, we have to consider various type of multiple failures in this plate that can happen once the tensile loading is applied. So upon application of tensile loading, let us say this pull is there of P. You can start from any side, either the left side, right side, that doesn't matter. But there are some, you can say, ways through which you need to see how the failures will come. So failure generally starts from the top of the portion and then it penetrates downward. This is how the tearing progresses. So let us say the first possible failure path is like this. That means it goes straight away like this. For reference, let us say some numbering we will take. Let us say this is 0.1, 0.2, 0.3 and finally 0.4. So this is the path. Okay. Likewise, you have to consider multiple paths, and whichever the path that will be giving us the least amount of area or least amount of, you can say, distance, that would be basically the net minimum width value, and that eventually will lead to the net minimum area. Alright. So let us see how to analyze it. Like I said, you will be requiring different path. You have to see the different paths. We'll write down over here. First, we have to see what path we are considering. Then, in that path, my dear, we have to see how many bolt holes will come. Because the more number of bolt holes you have, lesser would be the value of width available. So, number of bolt hole, this is an important factor. And the next thing is number of staggering length you have to see. That how many times you have considered a staggered length. Because more staggering failure you will consider, the more width will come. Number of staggering leg. Once you have these three parameters, my dear, you will be able to find out the net width. Then you will be able to find out net width. So this is how we generally solve this question. Alright, my dear. So what path we have considered right now? We have considered a path 1, 2, 3 and 4. This is the path we have considered. Okay, just a straight crack, just like in a chain pattern. So when it goes straight away, the number of holes came into the picture were 2. The number of holes that came into the picture were 2. How many staggerings? That means how much inclined cracks you have considered in this. There was no inclined crack. You have taken the crack just straight away, perpendicular to the line of action of loading. Nothing was inclined. So there was no staggering leg. That is means 0. So what is the net width? It would be total width minus 2 bolt holes gone. 2 bolt holes of D naught size gone. So total width was 210 minus twice of what was D naught? D naught came out to be 20. So this becomes 210 minus 40, that means 170 millimeters. So this is your net width along path 1, 2, 3, 4. Likewise, you have to consider cases, all the possible cases through which you can see the net width might outcome to be the minimum. So in order to get the minimum value of net width, you have to see your number of bolt holes would be as maximum as possible. So my dear, always try to consider a case where you might have a number of bolt hole larger than the previous value. So here you have number of bolt holes 2 at a 0 staggering. So try to consider a case where you have a higher number of bolt holes, let us say 3. So let us now see in which case we will get 3 number of bolt holes. So this is the diagram, how to get 3 number of bolt holes. So my dear, 3 number of bolt holes could come like this. So 1, 2, instead of 2, let us say it went over here like this, and then it went straight away like this. Okay, now what is the advantage of considering this path? The advantage of considering this path is that 1, 2, 3, 4, let us say this point is 5, this point is 6. Along this path 1, 2, 5, 6, how many bolt holes we have? We now have a 3 bolt holes. So there might be a possibility that the net width value might come minimum out from this case. So let us now check. So now we have considered 1, 2 and 5, 6. So along path 1, 2, 5, 6, 1, 2, 5, 6. How many bolt holes gone? 3. Is there any inclination? Was there? Yes, there was some inclination. There was one staggering leg. So there was one staggering leg. We have to add some value for this. So net width would be equal to total width minus number of bolt holes gone. That is how much? 3 times 20. But now you need to add something. You need to add something for what? One inclination crack that you have considered. You need to add some value for that as per the code expression. So what is the rule? P square by 4G rule is there. So how much pitch you have covered in this staggering? From 2 to 5 staggering, my dear, you have covered a pitch of how much? 40. From 2 to 5, you have covered a pitch of 40 at a gauge distance of 50. So this you need to add it up over here. P square by 4G. That means we will write down plus there is one leg of P square, that is 40 square by 4G. What is gauge distance? 50. Solving this will give you the minimum width value along this path. So solving this, we are getting 40 square by 158. So I'm getting the value as 158. So as you can see, this value is lesser than the previous one. This value is lesser than the previous value. Previously what we have got in the straight crack. In straight crack it came out to be 170 millimeters, but along path 1, 2, 5, 6, that means first the crack will initiate from 1 to 2, then an inclination from 2 to 5, and then the straight crack. In that scenario, my dear, the length required to cover for the fracture is lesser. So definitely that would be preferred over the bigger one. So when we compare both of them, of course 158 is the minimum one. Along this, the crack possibility is much higher. Let us see the another possibilities as well. So like I said, what is the rule? Consider a case where you get a higher number of bolt holes. Okay, so what is the next case where you can get a higher number of bolt holes? Up till now we have seen 3 bolt holes. Now many of you might say, sir, there are other paths as well. There might be a failure along a path 1, 2, 5, 3, 4. Yes, there is a possibility 2, 5, 3 bolt holes are there, but I don't think so. Why it will be the final case? Because 2 to 5 you have added something, then again for 5 to 3 you will add something. So my dear, definitely when you will add twice of the inclined leg, you will get a more width, and our main focus is to get the value where the net width is minimum. So my dear, there is no, you can say, a requirement of finding out the net width along 1, 2, 5, 3, 4, because you will be getting same number of bolt holes with 2 staggering legs. So definitely it will result into a larger value of width. So I don't think so. There is no need to put your time in that particular case. Yes, and any other case you can think of, you can see like this. So 1, 2, 5. Now it might even go over here like this, and then straight away like this. It can be a possibility. Let us say this is point number 7 and this is point number 8. So in this scenario, my dear, what will happen? At 2 you have a bolt hole, at 5 you have a bolt hole, at 7 you have a bolt hole, then it has been finished. So how many bolt holes? 3. 3 we have already taken. How many staggering legs? 1, 2. So again 2 times it would be added. So again, my dear, no point of investing your time in such case. You have to invest your time in those cases only where you have a higher number of bolt holes as compared to the previous one, or equal number of bolt holes with lesser number of staggerings. Right now I have considered only one staggering. Without having any staggering, getting 3 number of bolt holes, that is impossible for this type of connection shown over here. So better you consider the case where you have 4 bolt holes at least. So how to get the 4 bolt holes? This should be our agenda. So the 4 bolt holes might come like this. Okay, let us say this is 0.9 and this is 10. Now you can see along this path, my dear, starting from 1, 2, 5, 7, 9. There are 4 bolt holes over here. And how many staggerings you need to add up? From 2 to 5 you will add, from 5 to 7 you will add, and then from 7 to 9 you will add. So 3 staggerings you need to add it up. So this is a unique case. You can solve this out. So 1, 2, 5, 7, 9. Let us consider a path 1, 2, 5, 7, 9. So path is 1, 2, 5, 7, 9, and then finally 10. This is the path we have considered. How many bolt holes gone? 4. How many staggerings required? 3. So solving this will get you 120 minus 4 times 20, but you have to add 3 times of 40 square by p square by 4g. So this you will get along this path. So what is the value coming out? 40 square by 4g. G is 50. So my dear, I am getting a value of 154 millimeters. So it is coming out to be lesser than the previous case where we had 3 bolt holes with 1 staggering leg. So my dear, yes, this will be even more critical than the previous case. 40 square by 4g. Just cross verify your answer. Yes, 154 millimeters. So this case has a more possibility as compared to the previous all cases that we have discussed. Let us see how we can have any other case. That means we might have a 4 bolt holes, more than 4 bolt holes, or 4 bolt holes with lesser number of staggering. Let us see that. So can we have 5 bolt holes in this case? Can we have a crack orientation in which we can have a 5 bolt holes? I don't think so. Starting from top to bottom, at max, my dear, you can have 4 bolt holes only. 5 is not possible. Now check it out whether you can have 4 bolt holes with a lesser number of staggering. So my dear, let us see a path like this. 1, 2, 5, 3, and then you can say 6, like this. There might be a possibility 1, 2, 5, 3, and then it went over here at this point 6, let us say, like this. So in this case there are how many bolt holes? 1, 2, 3, 4. There are 4 bolt holes, and how many staggering you have considered? From 2 to 5 you will consider, from 5 to 3 you will consider, and then from 3 to 6 you will consider. That means 3 staggerings will come. That is not a unique case. We have already found out by having 4 bolt holes and 3 inclined legs, same value will come, 154. Yes, any other possibility you might have think of? You might think of 1, 2, 5, 7, and then it went towards, instead of 9, 6. In this case also, my dear, 2, 5, 7, 6, 4 bolt holes, but number of staggerings will be 2 to 5, 5 to 7, and again 7 to 6. So I don't think so. You will be finding out the unique case. That means all of these cases where you are getting number of bolt holes 4 and 3 staggerings, you will be getting the same value only, that is 154, because the pitch and gauge distance provided is same. If they would have been different, then you need to calculate it up. But because of the symmetry, I don't think so. You will be getting a different value. So whether you take path 1, 2, 5, 3, 6, whether you take part 1, 2, 5, 7, 6, you will be getting the same value only. So my dear, based upon this analysis, what I can write down? That based upon this analysis, the minimum value of width that we are getting out of all the cases is 154 millimeters. So this would be our critical width. Along this, you will say our failure will occur when the loading would be equal to the limiting strength value. Alright, if you want to find out the area, then if the thickness of the plate is known to you, all you need to do is just multiply the thickness over this, you will get the net area. Alright my dear, so this minimum value is nothing but our final minimum width. Okay, so the answer is 154 millimeters.